This is like the hardest question that I've ever been this year. Apart from the stuff on the that last question.
Oh yeah.
I figured out like
I didn't even do that one.
I just put 1850.
I just put
I see TikToks about that.
Let's talk about the graphs. When you start graphing, you should be graphing y equals 2x and y equals 20 minus half x. And we're looking for the point of intersection. That's our solution here. Okay? Some of you scale the axes by different things, so then it got a little tricky. When you have a slope of negative 1/2, you go down 1, right 2. And hopefully you graphed out enough so you could see a nice accurate point. Okay? And then we'll graph y equals 2x. It starts at the origin because it has no y-intercept. From there, we should find our intersection point. Who can tell me what's the point of intersection? 816. 816. Do we agree, teams? Did we get 816?
Yes.
Great. What does this mean? What does this mean in terms of the word problem?
Xylophones and 16 motors.
Yeah, we've got 8 xylophones on the gondola, and we've got 16 yodelers. Did you guys realize why I was using xylophones and yodelers? X, Y, yeah. Yeah, it seems funny, but they're X and Y, and that made it a little easier here to graph. When we are graphing two linear equations, our solution is a point of intersection, okay? And this is an example with a word problem. Any questions about the word problem today?
What's a gondola?
Graph. I can graph linear equations as a system and find a solution. Our first example had a nice solution. We found the point of intersection, all of that. I told you that you wanted to write your equation and y equals mx plus b. One of the equations was in a different form. What is that form? Yes. Standard. Okay, and you guys did great with the standard form. You solved for y so that we could graph it. The third form of linear equations we talked about earlier this year was point slope. Okay, which one do you think is the easiest to graph? Yeah, y equals mx plus b, and you guys already did that in our first problem together. You took that standard form and you solved it for y, so it was easier to graph. Here's our first example. We're going to graph these two equations and find the points of intersection. So go ahead. Let's graph these two equations and find the point of intersection.
Oh yeah, I see it.
So when we graph, it actually intersects when x is 1.5. So that's why it might be a little harder to see, but still definitely something we can graph by hand and find. Okay, it sounds like some of you already started graphing example 2. Let's look at it together. You've got a y-intercept of 1 and a y-intercept of 3. Some of you already noticed that they are parallel lines. How can I tell from the equation that they're parallel lines?
The same. The X's are the same.
Same slope. Not the x's are the same slope. So yes, we will have parallel lines. They never intersect. So, in this example, I would write down same slope. Okay, lines. Why is this a special case? Parallel lines never intersect. So if I am asked to find the solution to this system of equations, your answer here would be no solution. Make sure you add that to this example. Your answer would be no solution. If you were asked why on a question, you would say, well, they're parallel and they will never intersect. No solution. I'm not getting a point of intersection like we did in the other examples. Another special case here. The second equation's not in slope-intercept form. So if we change this, so I'm going to simplify 6 over 2 is 3. Oh my goodness. If I add y to both sides, what do you notice?
It's the same exact line.
It's the same exact equation. Yeah. So this can happen in a system. All right, we can graph this. It's going to be the same line overlapping. Okay, so we have the same line. They overlap. So when I'm asked about how many points of intersection there are for these two equations, what would you say? Infinite. So in this case, I have infinite solutions because they're overlapping each other. So that is a possibility. When you're solving a system of equations, you might get the same equation and it's infinite solutions. Any questions on this second special case? Things that are difficult to graph by hand. Why? What might be some scenarios where things are difficult to graph by hand?
No ruler.
No ruler? Look at the system. Look at the system. Why might they be difficult to graph?
Because they're both fractions.
We might have fractions. You're right, or decimals. There might be an example where you might have really or very large numbers where it would not be easy to graph by hand. And I've got some steps for you here. If you've got an equation like this one, where it's not in slope-intercept form, y equals mx plus b, you want to solve it for y first. Okay, so I'm going to take this equation, and I'm going to solve it for y. I'm going to minus 7 from both sides first. Then I'm going to add 2x to both sides. So now I've got y equals 2x minus 7. I still have this one with fractions. I still need to find the solution to this system. So we're going to use the graphing calculator or Desmos. If you have a graphing calculator, at least one per pair. We'll do this together. Graphing calculator, at least one per pair. If you could share them at your table. On the graphing calculator, we talked about this during absolute value. When we graphed absolute value. You guys remember where to go? What button should I click first?
The top left.
Y equals. If there's any equations in there, clear them out. When I type in fractions, I need to use parentheses. So 4 divided by 3. And I put it in parentheses here. I hope we're paying attention because you might have a parenthesis or a fraction problem. Okay? If you have to type in a fraction, use parentheses. Our equation was 4/3 x plus 4/3. Okay? That's just the first example. Close it with parentheses. Y2. And we're going to type in what for this one? 2x minus 7. And then we're going to graph them. Do you see how we cannot see the point of intersection?
Yeah.
So go to zoom. Go to zoom. And you can go down to the option where it says zoom fit. And it should fit to the intersection. Let's see what it does here.
What button do I press after zoom?
It did not.
Mine do intersect because I put the negative in the 4/3. There's a negative on the 4/3 slope.
Okay, great. Love it. Let's
I don't know why it doesn't automatically put you at the intersection.
because it's TI-84. Here's another option. Desmos. Y equals. Shh.
There was too many steps though. I'd have to.